Hello everyone, hope you all are doing great. Guys, today in this video we are going to understand sixth attribute of BGP, that is MAD. MED. MAD stands for multi-exit discriminator. MAD is nothing but your metric. It is metric. So as you know, lower metric always preferred. In IBGP we have discussed these things lots of time. In OSPF, EIGRP, that lower metric is always preferred. So in BGP also, lower MAD is always preferred. Guys, before starting configuration, try to understand what is MAD. What is MED attribute? So MED attribute is used to advertise your neighbor. It is used to advertise your neighbor that how they should enter in your ES. Like in this topology, in my scenario, you can see I have two ES. ES100 and ES200. So through this attribute, I can tell to router number 4 that you should use which path to enter in my ES100. Because router 4 have two choice to enter in ES100. It can enter via router number 2 or it can enter via router number 3. And with the help of this attribute, MAD attribute, I can tell to router 4 that you should enter in my ES via which router. That's all. Done. So hope now it's clear to you that what is MAD. So MAD is used to tell to neighbor router they should use which path to enter in my ES. Like here you can see on router number 1 I am advertising these prefixes in BGP. So router 1 will advertise to router 2 and to router 3 to their all neighbor. In the same way, router 2 and router 3 will advertise to router number 4. Maybe router 4 will use best path via router number 2, right, on the basis of which attribute. But actually router 4 will use best path on the basis of oldest path, on the basis of oldest path attribute, because next hop will be reachable, weight will be same, after that local preference will be same, after that self advertise both from both neighbor it is receiving, ES path will be same, origin code will be same, then it is going to check metric, so metric will be also same, then it is going to check external over internal, so both neighbor are external, then it is going to check IGP cost to reach next hop, so IGP cost to reach next hop will be also same from both sides, then it is going to check what oldest path in case of eBGP. So both neighbor are eBGP, so it is going to use this attribute for best path selection. Okay, first of all let me configure BGP over here and then I will show you practically what is the use of MAD. Okay, so just be here guys. Let me take access of all routers. Router 1, router 2, router 3 and router number 4. Now first of all let me check the configuration. I think I have configured IP address only on these routers. Enable show IP interface brief exclude unassigned. Okay, so I have created this loopback. After that, between router 1 and router 2 I am using 12 network. Between router 1 and router 3 I am using 13 network. In the same way, between router 2 and router 4 I am using 24 network. Okay, between router 3 and router 4 I am using 34 network. Done. Let me check the BGP configuration. So IP protocol BGP 100 is running. Let me check how many command I have run. So run section BGP. No, I need to define the neighbor now in BGP. So let me take you in BGP config mode. Router BGP 100 and neighbor is 12.1.1.2 whose remote AS is 100. After that there is one more neighbor 13.1.1.3, 13.1.1.3. so let me correct it over here. Right, remote AS is 100 and now I am going to advertise network 10.1.1.0, mask is 255.255.255.0, Let me advertise other prefixes as well. 2, 3.0, 4.0 and 5.0. Done. Now I am going to configure BGP on router number 3. Let's say enable config T. First of all, let me configure router 2. So IP interface brief. So okay, you can see the IP configuration. So IP protocol, I am not running any protocol over here. So let me configure BGP router BGP 100 and neighbor is 12.1.1.1 whose remote AS is 100, and there is one more neighbor 24.1.1.4 whose remote AS is 200. Right. Now configuration of router 2 is also done. Let me take you on router number 3. A router BGP 100 and neighbor is 13.1.1.1 and remote AS is 100 and neighbor 34.1.1.4 remote AS is 200. Done. BGP configuration on router 3 is also done. If you will check BGP table, so IP BGP, you can see this router have received all 10 prefixes. These are not best, only valid. So wait, these prefixes is not only valid, it will become best as well. So IP BGP is summary neighbor is fine with router number 1. So IP BGP, this next hop is reachable or not from here. Ping 13.1.1.1. Yes. So IP BGP on router number 2, let me check. So IP BGP, so these are valid as well as best. So router 3 on router number 3, these prefixes will also become best. Clear. IP BGP star soft in, and so IP BGP, so IP interface brief. Okay, everything is fine then. So IP BGP, so now you can see these prefixes are valid as well as based on router number 3. Now I am going to configure router 4. So config T router BGP 200 and neighbor is 24.1.1.2 and remote AS of this neighbor is 100, and there is one more neighbor 34.1.1.3 whose remote AS is also 100. Right. Now if you will check BGP table, so IP BGP, so you can see these are only valid now. Soon it is going to become best and it is going to receive from both neighbor. So now you can see the BGP table of router 4. Router 4 have received 10.1.1.0/24 network from router 2 also and from router number 3 also. This is the IP address of router 3. This is the IP address of router 2. And best is via router number 2 because of oldest path. Okay. So if I will down the neighbor with router number 2, best path will become via router number 3. So let me do that also so that it will be very clear to you that router 4 is selecting best path on the basis of oldest path. Okay. So what I am going to do, router BGP 200 and say neighbor 24.1.1.2 and shut down. So I have shut down, graceful shut down the neighbor. Now if you will check BGP table, do so IP BGP. So now you can see all prefixes are based via router number 3. Again I am going to up this neighbor, say no shut. Right. And now if you will check BGP table, you can see all prefixes are based via router number 3. Via router number 3. Done. Okay. So router 4 will install path, routes in their routing table via router number 3. All prefixes via router number 3. If you want to verify, do so. IP route BGP. So here you can see all prefixes are reachable via router number 3, 34.1.1.3. So router 4 is entering in AS100 via router number 3 now. Yes or no? But suppose I want to enter in my AS, what I want, whenever AS200 will enter in my AS, it should enter via router number 1. So what we can do, we can add some metric over here. Then best path selection will happen on router number 4 on the basis of MAD attribute, on the basis of 6th attribute of BGP. Now it is best path selection is happening on the basis of 10th attribute, oldest path first. But if I will send some metric from here, then it will select best path on the basis of 6th attribute. Now you can check the MAD value on router number 4. Do so IP BGP. Here you can see. Let me maximize it. From both sides, metric is blank. Yes or no? So now what I am going to do on router number 3, from router number 3, actually I am going to send some metric. So I will set metric, let's say 100 over here. So what will happen, from here metric is coming blank and from here metric will come 100. So as you know, lower is always preferred. Then router 4 will start using this path via router number 2. So then AS number 200 will enter in AS number 100 via router number 2. Let me do that. For that, on router number 3, you need to create one route map. So here let me create one route map, and let's say name is MAD of this route map. And in this route map I am going to set metric, let's say 100. Here I am going to set metric 100. Okay, exit. Now router BGP 100 and neighbor 34.1.1.4 use route map MAD. In which direction? In odd direction. You will always apply MAD in odd direction. Okay. After that, clear IP BGP star soft in. Clear IP BGP star soft in. And now on router number 4, if you will check the BGP table, so here also we need to clear IP BGP star soft in. And now if you will check BGP table, so IP BGP, you can see from router number 3 MAD is 100, from router number 2 MAD is what? 0, blank. Yes or no? So now again best path is via router number 2. Best path is via router number 2. So you know how I am manipulating path with the help of MAD. Actually you can add MAD value, right? Metric value via router number 3. So definitely router 4 will start using best path via router number 2, because from router number 2 it is getting list metric. Yes or no? So this is via router number 2, metric is blank. This is via router number 3, metric is 100. Lower metric is always preferred. So now so IP route BGP, you can see all prefixes are reachable via router number 2. Okay. Now I am going to remove the configuration from router number 3, route map configuration. Say router BGP 100 and neighbor 34.1.1.1 and route map MAD. I am going to say no. Right, I have removed this configuration. Let me remove route map as well. No route map MAD. Okay, done. Now suppose my requirement is whenever AS number 200 will enter in my AS 100, for these three prefixes, it should enter via router number 2, and for these two prefixes it should enter via router number 3. That also we can achieve it with the help of MAD. Right, what is my requirement? For these three prefixes it should install best path via router number 2, and for last two prefixes it should install best path via router number 3. So for that, what we can do here, we can configure one prefix list to define these networks as interesting, and for these prefixes I will add metric. Let's say for these prefixes I will add metric on router number 3, let's say 100, and for these two prefixes I will add metric 100 over here. Okay, so what will happen when router 4 will receive these three prefixes? It will receive list metric via router number 2. So via router number 2 it will become best path for upper 3 networks. For lower 3 prefixes networks, here I have router number 2, I will add some metric. So router 4 will receive list metric via router number 3, so it will install this path in their routing table for these two prefixes. Okay, let me do that. Let me do this practically so that it will make you more clear. So on router number 2 I am going to configure first. On router number 2 I am going to add some metric for upper 3 networks. So first of all I have to define interesting traffic. And what will be the summary address of these 3 network, guys? Summary address will be 10.1.0.0. You can calculate /22. So let me create one prefix list. IP prefix list name is, let's say, CCI. After that, permit. And which network? Summary address 10.1.0.0/22. This is the summary address of upper 3 networks. After that, greater than equal to 24 and less than equal to 24. Done. Now I am going to create one route map. And here route map name is mad, and let's say permit. Okay, here I am going to match IP address from the prefix list. Match IP address prefix list CCI. Okay, so from here it is going to match IP address. In this prefix list I have defined this summary address. Okay, and now I am going to say set metric 100. Done. So if you have matched this IP address from prefix list, it will deny all other. So you have to create one more route map mad, say permit with higher sequence number, and here I am not going to match anything, so it will match all. Now I am going to use this route map in BGP. Router BGP 100 and neighbor 24.1.1.4. use route map mad in which direction? In odd direction. Done. Now on router number 4, if you will clear BGP, clear IP BGP star soft in, and the show IP BGP. So you can see for this prefix, upper 3 prefixes, via router number 2 prefixes is coming with MAT 100, metric 100. Yes or no? So that is the reason this network is best via router number 3. This network is also best via router number 3, and this network is also best via router number 3. But this network is still best via router number 2. This network is still best via router number 2. Done. Here MAD is 0 via router number 3. Now, so these upper 3 prefixes are best via router number 3. Now I want to make these 2 prefixes best via router number 2. So it is still best via router number 2. But if you want to set some metric for these 2 networks on router number 3, you can do that also, right? Because now still for lower 2 prefixes, router 4 is selecting best path on the basis of oldest path. Okay, so on router number 3 also you can create one prefix list, IP prefix list. Let's say name is again CCI permit, and the summary address of last lower 2 address will be 10.1.4.0/22 and greater than equal to 24 and less than equal to 24. I'm going to use this prefix list in route map. Let's say mad over here also, say permit and match IP address prefix list CCI, and here I am going to set metric, let's say 200. Okay, and one route map for permit, route map mad permit, and higher sequence number is 20. Done. Now router BGP 100 and neighbor is 34.1.1.4. use route map Which route map? MAD. In which direction? In odd direction. Right. Now let me take you on router number 4, and first of all clear BGP and show IP BGP. Now you can see for these two prefixes router 3 is sending metric 200 and router 2 is not sending any metric, so it have installed best via router number 2, right? For these two prefixes, now you can see best path is router number 2, and for these three prefixes best path is router number 3. So if this router will ping, let me create one loopback on router number 4 also, guys. Router one loopback here I am going to create. Interface loopback, let's say 1, and IP address is 40.1.1.1 255.255.255.0. Done. Now I am going to advertise this network in BGP. So router BGP 200 and network 40.1.1.0, mask is 255.255.255.0. Done. So router 1 have received 40 network or not. Let me check. Enable show IP BGP. So it have received 40 prefixes but not best only valid, because next hop IP address is not reachable. Next hop IP address is not reachable. So on router 2 and router 3 I am going to say update next hop self. Update next hop self router BGP 100 and your neighbor is 12.1.1.1. For this neighbor update next hop self, and let me run this command on router number 3 also. Neighbor 13.1.1.1 and next hop self. Done. Now on router number 1, if you will clear IP BGP star soft in, you can check so IP BGP. So now this is best via router number 2. Via router number 2 it is best, right? Because now router 1 is selecting best path on the basis of lower router ID, lower neighbor router ID. So router 2 have lower neighbor router ID, so because of that it is best path. Done. Now from router number 4, if I will ping 10.1.1.1 and source is 40.1.1.1. See, ping is working. If you will trace route 10.1.1.1 and source is 40.1.1.1, you can see your traffic will go via router number 3. It is testing, it will take some time. See, traffic is going via router number 3. But if you will trace 10.1.4.1, then traffic will go via router number 2. So let me trace now this network. Let's say 40.1, 4.1, sorry. So that means whenever router 4 will enter in my AS for upper 3 networks, it will enter via router number 3, and whenever router 4 will enter in AS 100 for lower 2 networks, it will enter via router number 2. Here you can see this is the MAD attribute. Lots of time interviewer is asking question from this attribute. So hope now MAD is clear to you. If you have learned something from this video, guys, please hit on like button. That's all for today. We will meet soon in next video. Till then, stay safe. Bye bye.